Oops, x minus 7. Harsh. Look at you. Nice work. He's on fire. Jalem.
2x plus 5, x minus 1.
Woo, doggy. Who next? Marley.
X squared plus 1, x squared minus 1.
Half a mark.
Oh.
How does he finish it?
You gotta x squared.
X plus 1, x minus 1.
Yeah.
5. Who am I up to? Kian, hit me. X minus 12, x minus 5. Nicely done. 6. Who am I up to? Gagmeet, hit me.
8 plus 11, 8 minus 1.
Woo! We are on the proverbial roll. Call me mint jelly because I'm on the lamb. Anyone? On the lamb means you're running from the law. And you put mint jelly on lamb. Well, people in Britain do. I don't really know why lamb requires mint. But people in Britain love mint jelly on lamb.
Have you ever tried it?
Yes.
It's pretty good.
It's okay. It makes your food taste minty, like you're brushing your teeth. If you like the taste of lamb, why would you cover it with mint?
Yeah. Do you like the, do you use the vinegary version of that? Like, it's not the good one. There's like different versions of mint jelly. There's like
No, I have never heard of vinegary mint jelly.
yeah, it just has like a lot of vinegar.
Yeah, but like, I like the taste of popcorn. And sometimes I also put this sugar stuff in it.
Jazz Reet!
Sometimes I serve sandwiches.
Jazz Reet!
Those are good.
Honey sandwiches too.
Absolutely correct. 8. Hallie.
A bracket, A minus 1, A plus 1.
Well done. 9. Rhea.
8, A minus 3, A plus 3, A minus 3.
Yep, absolutely correct. 10. Poor Damaris gets 10. Everybody, when I start doing it this way, everybody in the middle row starts going to hope that they don't get 10. But you don't know where I'm going in the middle row. Am I going across the hall or am I going back up to the front? What is it?
X minus 1 third, X plus 1 third.
Close.
Oh, that's what I did.
1/3 minus x. 1/3 plus. It does matter because what Damaris said was x minus 1/3
That's what I did.
and x plus 1/3. Do the math. Foil it out. What's x times x? X squared. I need negative x squared.
Oh. I saw
Oh.
reverse the operation.
Yeah. I know, right? So close. If only I connected the right aortic valve to the right aortic valve and the person wouldn't have died. I was so close. Maybe they'll give me a rewrite. Oh no, wait, it's a corpse.
This is grade 10, man. Lighten up a little.
Dude, when are you guys going to start realizing that I was close isn't good enough? When is it going to kick in though? You've been let go for 11 years of school with, oh, I'm sorry, Mrs. Van Crumble. I spelled laugh, L-A-F-F again.
Yeah, but you made a whole rant about how this sounds A-U-G-A.
I know I did. Which is why you actually have to learn how to spell it. Right? Because good enough is not.
Although at this point we have autocorrect.
Yeah.
I get what you're trying to say, but just look it up a little. We're still learning. We still got years to go.
Okay.
Years to go. It's like 2 more until you're at uni.
Years to go. If by years you mean more than 1, yes. Which is 2.
Well, we have a class. Most of us are going to university.
Okay. And do you think at university your professors will allow, close enough?
No, but that's what we're trying to learn. Like, we get it.
That's why I continue to tell you. 11. Joy. 12. Paul.
Are you gonna write the ACT this
Will I accept x plus 3 squared?
Yeah.
Of course I will.
That's good enough.
13. Joseph.
X to the 4 plus 4, x squared plus 2, x squared wins.
Abso-smurfly correct. Give yourself a mark out of 13. Is everybody good? All right. Now, listen to me and listen to me closely. There is one more type of factoring to learn. Then you must be aware that all 4 kinds of factoring can be included in one single question. You must be able to use all 4 types whenever they apply. All right? When I teach you this third way to do factoring, I personally know of 3 methods to do this third way. 1, everybody from another country has already seen it, and they use that. I do not like that method because sometimes it requires you to guess. And guessing and checking is not math. There is a second way that you can do and not ever have to guess, but it requires you to be very good at very good at this kind of factoring. If you're not very good at that, you're not going to like that method. Then I'm going to give you a third method that you never have to guess. I'm just waiting because everybody's having important conversations about factoring. They're obviously discussing the positive and negative merits of the 2 methods I've already outlined in order for them to make a better decision on which method they would like to use when it is time.
How did you know?
I know, right? It's people say that I'm a very with it kind of guy. I understand what's going on in my classroom. And to which I reply, yes, I do. My students never shut up and then complain when they don't know how to do something. The third method requires you to know a previous method and then do one more weird step. I am going to show you all 3. I do not care which method you use. Okay? So if you are from a different country and you are comfortable with that method of factoring, use it. If you are comfortable with this kind of factoring, use it. If you are comfortable with the third method I show you, which I believe to be the easiest and best method, use it. They are all valid. I am very bad at the other country method. I hate it. I will show you it because some students like it best, even though I do not. And it is not up to me to force my opinions onto you people. Aight? Aight. Everybody turn to page 166.
Do you think
without the
If I ask you to expand that,
Ew. Oh, that was Ew. Why you don't want to go? Oh my god.
and then if I asked you to factor that, you would need to multiply to 24 and add to 10, correct? Everyone agree? All right, now, from there, I'm going to show you all three methods, and then we're going to apply it to this more difficult one. All right? Step 1, expand this. 6x squared plus, I lie, minus 4x plus 3x minus 2. I wrote it all in one line on purpose. Please notice that this is just where I would put that down there. Is everybody cool? Everybody's good? Okay. Now, working from here, do not write down what I'm about to write down. Just watch.
Okay.
The way we would factor this right now is we would want the red, right? We want numbers that multiply to 24 and add to 10, correct? Everyone agree? And we would get what? X plus 6 and x plus 4, which we already know because over here it's already factored, yes? All right. So since you can all factor that in your sleep, I'm going to use that as my method, how to show you how all three methods work if this number doesn't equal 1. Because right now it equals 1, right? Method 1. In the first method, and don't write this down, I'm just going to talk about it. In the first method, this is the other countries method. This is taught all over the world, and it's even taught in Canada. A great many of the student teachers I have had use this method. I do not like it. Because sometimes, a lot of the time, it requires you to try a bunch of different combinations until you get the right one. The other two methods I'm going to show you the right combination on the very first try. Okay? Which would be better if you were trying to break into a safe? Trying 4 or 5 different combinations or having the right combination the very first time? Having the right combination the very first time. Okay? So, in other countries, and I may do this a little wrong, so please, if you use this method, tell me if I do it wrong. In most other countries, they do this. They look at this number, and they look at this number. And they know that their final answer is going to be 2 binomials, yes? And they know that when they FOIL this out, that has to multiply by that, correct? And that has to multiply by that at the end, correct? So they say, all right, I need factors. Oops. The red numbers are out here, and the green numbers are there, yes? And using this method, you create a box. And the first set of numbers are factors. See how the red is highlighted? This should be red. Are factors of this number. What are the only factors of 1? 1 and 1, right? So they would write 1 and 1. And then over here, in green, they know that the green has to be this number times this number, correct? So they need factors of 24. You with me? Now the factors of 24 are as follows. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Agreed? Now, the reason I do not like this method is because right away, now we know how easy this one is because we're good at factoring. Right away, I'm given 4 combinations, yes? And then you do this. 1 times 24 is 24. 1 times 1 is 1. Do 24 and 1 make 10 in any way? No, so that one's dead. 1 and 12 and 1 and 2. Do 2 and 12 make 10 in any way?
Yeah.
They do, right? How? One has to be positive, one has to be negative, correct? Since everything in here is positive, can I have a negative number? No, so that guy's dead. Then we go to here. 1 and 8 is 8. 1 and 3 is 3. Do 3 and 8 make 10? No, it can't be that one. Then we go to here, and it is 4 and 6, yes? So they have 1, 1, 4, 6. 1 times 6 is 6. 1 times 4 is 4. 6 and 4 is 10. Everything's positive, and then you write your answer out. 1 plus 4, x plus 4. 1 plus 6, x plus 6. And this method will work if this number over here is bigger than 1. Everybody with me? I'm about to show it working for you. I don't like it because it gives you all these combinations. When you use the method I taught you, multiply to 24, add to 10, what does it have to be? You know right away it has to be 4 and 6, correct? So I'm going to show you a method that eliminates all of these maybes and gives you the right answer right away. All right? If you're from another country or you've done factoring before, you may have seen this box method, which in math class, teachers often give questions that factor easily, so the box method works. And people are like, oh yeah, it's awesome. Until you're faced with a whole bunch of different choices in each side of the box. Then it becomes troublesome. Everybody cool? All right, now, method number 2. Method number 2 becomes this. I need numbers that multiply to 10, or multiply to 24 and add to 10, correct? X squared. I know it's 4 and 6, don't I? Right? What have I, when it shows up, just written? When it shows up. What would you do with those two numbers? You'd add them, and you would get x squared plus 10x plus 24, right? Does everybody see that those are the same? Yeah? Now watch. What would you do with that binomial if I just gave you that? You'd factor out an x, wouldn't you? And you would get x plus 4, correct? Everyone agree? What would you do with that? You'd factor out a 6, and you would get plus 6 and x plus 4, correct? What do you see there and there? Common factor. X plus 4, and what do you see there and there? The leftovers, x plus 6, which is the final answer, yes? Everybody with me? Everybody cool? All right. The third and what I think is best method to do this uses this that you already know and one extra step to eliminate all of this poo. Everybody okay? Let's do that now. All right. So, you all already know that these are the factors, right? If I expand it out and I get 6x squared minus x minus 2, that's my product, yes? And if I wanted to factor it in a factoring class, none of this would be visible, right? Because our goal is to break that down. Cool? Now let's break it down all three ways. We already know what the answer is. Let's break it down all three ways. All right? Method number 1, which is the one I don't like, but I'm showing to you because some kids really like it. I'm going to call this A, this B, and this C, right? Method number 1 means I make a box. What goes over here? Factors of A. What goes over here? Factors of C, right? What are the factors of A? It's got to be 1 and 6 or 2 and 3, correct? So I know it's 1 and 6 or 2 and 3. Yeah? No, it's only the A.
Okay.
Everybody cool? And what are the factors of C? Has to be 1 and 2, right? Then I go across. What's 1 times 2? 2. What's 1 times 6? 6. Do 6 and 2 make 1? No. All right, so now I check with 2 and 2. Does 2 and 2 is what? So this guy's out. What about 2 and 2? That's 4. 3 and 1. 3. Does that make 1? How? 3 minus 4, correct? So it must be 2x plus 1. Because that's the positive. And down here, it must be 3x minus 2 to get the negative. Does everyone see how that one works? Now, Amy, is that how you were taught to factor these? Excellent. Olivia? Is that how you were taught to factor these? You don't remember. Joseph? Right. This is how you guys were all taught to factor these, if you're from another country, right? Now, watch when it becomes a problem. Again, don't write down what I'm about to write down. There's A, there's C. What are my options for A?
4,
16 and 1. Or 2 and 8. Or 4 and 4. What are my options for 9?
3 and 3.
Or
9 and 1.
see all the choices? You can get to it eventually, but it requires trial and error. Is everybody cool? You will get the right answer. I don't like it because why would you use trial and error when you can get it first try?
First time, every time.
So let's go back and let's work on that. Yes, go ahead. Again, if you like this method, use it.
Honestly, use every method. Forget one method at one time.
I don't care.
Pretty fun.
Method 2. Method 2. Remember, this is what we're working with. In method 2, you take A, you multiply it by C, and then you find factors to add to B. So what is A times C here?
12.
Negative 12. So now I need factors of 6 times negative 2, which is negative 12, that add to b. What are the factors of 12 that add to negative 1? We know it's 4 minus 3, correct? Or 3 minus 4, right? Hey.
Negative square speakers.
There's a bunch of speakers back there. I don't know what have plugs and what doesn't. We know this is negative 4 plus 3, correct? So we take this and we write it out like this. You take the bigger number. Even though it's negative, you take the bigger number. 6x squared plus, not plus you idiot, minus 4x plus 3x minus 2. Then you factor.
So
What comes out of there? 2x. 3x minus 2. What comes out of there?
nothing.
1
I
plus 1. 3x minus 2. And what do you notice?
noticed that we can do the
Common factor. 3x minus 2, 2x plus 1. Our answer.
I'll call it the smooshie method. You do smooshie.
Is everybody good?
Yeah.
This method is called decomposition. Because you are decomposing x into two different numbers.
It's a cool number.
What? I don't care. Yes. Remind me next week to start that you can go to the washroom once a week policy. Because I am very tired of it. And finally, the third method that I like the best, that will never screw you up, never give you the wrong answer, never make you have to do anything difficult, because it always, always works. If you have to go, go. Then why would you ask?
Because she had to go.
You just check it. They just check it. You're just making sure.
Here is what you do. It starts the same way.
Yeah, because there's no L. There's no L.
You still do A times C to get negative 12. And now here's where it changes. This is different than this because of that 6, yes? That 6 is 6 times bigger than that, correct? In the old method, we wanted factors of 24 because that was a 1. Now, I need factors of 12 because this is 6 times bigger. Everybody with me? All right. So I want factors of negative 12, but here's where it gets weird. You still leave this as 1. So it is x plus 3 and x minus 4, correct? But it's not really 3 and 4, is it? Because I multiplied by 6 at the very beginning, didn't I? Right? So, if I multiply by 6 at the beginning to know that it was 3 and 4, what must I do at the end to simplify that multiplication?
Divide by 6.
I must divide by 6.
Wait.
Now, would you ever leave that fraction for Mrs. Bad Crumble?
Oh no.
No, what would you write? You would write 1/2, correct? Would you ever leave that fraction for Mrs. Bad Crumble? What would you write? 2/3. Now, when you get to here, this is where the magic happens. The denominator goes to the front. And what do I get?
The same damn thing.
The same thing using a method that you're already comfortable with. This one. Does everybody follow?
Yeah, but
Now.
this requires you to know the math.
I always like to show you why something works, correct? Don't write this down. Watch what is happening. 6x squared minus x minus 2, correct?
Alright.
The reason this is difficult is that 6 is there and we can't get rid of it, correct? I can't GCF that 6 out of there, can I? Okay? But if this was just x squared, we know how to factor that, don't we? So what would get rid of that? If I divided this all by 6, would that get rid of the 6?
Yeah.
What would I then have?
X squared.
X squared minus 1/6 x, right? Minus 1/3, correct?
All right.
Does everyone agree? Now, if we were factoring this, I would need to multiply to negative 1/3 and add to negative 1/6, correct? Everybody with me?
That's weird.
Everybody understands, right? Okay. Now, this is very difficult to fathom, right? But remember, when we did my method, at one point we were at this spot, right? Right? That's where we got to, yeah? We got it, I got it right here. Right? X plus 1/2, x, minus 2/3. Is everybody with me? Right? Now watch. What is x times x? X squared. What is x times negative 2/3? Negative 2/3 x. What is 1/2 times x?
Half of X.
Plus 1/2 x. And what is 1/2 times 2/3? No.
6.
Negative 2/6, correct? Can I add those together right now? What would be the common denominator there?
6.
Minus 4/6 x plus 3/6 x minus 2/6, correct?
Uh-oh.
What is 4 minus 3? Or negative 4 plus 3?
Negative 6.
X squared minus 1/6 x minus 2/6, correct?
All right.
What is 2/6?
1/3.
X squared minus 1/6 x minus 1/3, correct?
Okay.
What don't we like there?
We're dividing.
We don't like the fractions, do we? How do I get rid of divided by 6?
I'm also dividing by
How do I get rid of divided by 6? Multiply by 6, correct? What's 6 times x? 6x squared. What's 6 times negative 1/6? Negative x. What's 6 times negative 1/3?
2.
Negative 2.
Oh. What do you mean? That's easy. I'm on another planet now.
Do you see how it works? Even though my method looks like it shouldn't work, how do those fractions and moving that denominator work? You can see that it does. The only reason that we don't factor this like this is because you guys are so scared of fractions. Because when I wrote that, you guys were like, what? Multiply to 1/3 and add to 1/6? Yuck. Do I care what method you use? No. Now go back to your work and let's have a look. There's 3 questions here. I'm going to use one method on each of them. Okay? The first method I'm going to use, number 1, I'm going to use my method because the numbers are big. Right? Because if I use the box method, I got to have a bunch of guessing, don't I? So my method, I take A and I multiply by C. What is that? What's 20 times 10?
200.
I must multiply to 200 and add to what?
33.
33. Is it 1 and 200?
No.
2 and 100?
No.
4 and 50? 5 and 40?
Yes. No.
8 and 25?
Yeah.
Yeah. So it is B plus 8. But it's not really 8, is it? Because what did I do to get 8? I had to do times 20, didn't I?
So it's 8 over 20.
8 over 20. And B plus 25. But it's not really 25.
25 over 20.
25 over 20. What do you do with those fractions if you were in Mrs. Back Crumble's class?
Simplify.
simplify to what?
Where? Huh?
It's weird because my first grade teacher had a really long name, and it was really weird. Her name was Mrs. Apostolopoulos, and we were all in grade 1 trying to say that.
She's Greek. Or her husband is Greek. What is this?
That is 1/5.
2/5.
Oh.
What is this? 5/4. What do you do with the denominators at the end?
Multiply them to the coefficient.
Move them to the front. 5b plus 2 and 4b plus 5. And then you check. Is 5b times 4b 20b squared?
Yeah.
Yep. Is 2 times 5 10? So I'm done. No ifs, ands, or buts. It has to be that. Everybody cool? I don't care what way you use. This one, let's use the decomposition method.
Okay.
So step 1 is still times across there. So I need to multiply to what? Negative 30 and add to what?
10.
Negative 13.
Oh, yeah.
Is it 1 and 30?
No.
Is it 2 and 15?
Yes.
Yes. 3s squared. Since it's 2 and 15, which of those? One of them has to be negative, yes? Which one? Minus 15. Which is bigger, 15 or 2?
15.
15. So you put the bigger one first, plus 2s minus 10. Then you factor the groups. What's coming out of there? 3s. What's staying in there? S minus 5. What's coming out of there? Divide by 2. Plus 2. What stayed in there? S minus 5. 3s plus 2. S minus 5. And you check. Is 3s times s 3s squared?
Ooh, I like that.
Is 2 times negative 5 negative 10?
Yeah.
Is it right? Yes. Then we go to the third method, which is the box method. And again, I do not care if you use it. But before you do the box method, what are you going to do to number 3?
Factor GCF.
Why?
Because you can.
Because you can, and you always do that first. So that is 3, 2x squared minus 7x plus 3, correct? According to the box method, what goes down this side? Factors of A. What goes down this side? Factors of C. What are the factors of A? What are the only factors of A? 2 and 1.
Oh, what?
A. 2 and 1. What are the only factors of C? 3 and 1. Then we check. What's 2 times 1? 2. What's 3 times 1? 3. Does that make 7? No, so it can't be that. So then, this is why I don't like this one. I got to make a change. Which I can't do because it's frozen.
That's okay.
It is okay.
Life meant for it to be frozen. It's meant to be that way.
There we go. Okay. Change this to 1 and 3. What's 2 times 3? 6. What's 1 times 1? Will 6 and 1 make 7? If they're both what? Negative and negative. So it becomes 2x minus 1 and x minus 3 across at the end. Now I check. Is 2 times x 2x squared? Yep. Is negative 1 times negative 3 positive 3? Yep. If all of that multiplies by 3, do I get that? So I did it right. Choose your method. Use the one you like. Use all 3. Use one of them 99% of the time and use another one 1% of the time. Use one of them 33 1/3% of the time. Use another one 33 1/3% of the time. Use a third one 33 1/3% of the time. Use one 40% of the time. Use another one 30% of the time. Use another one 30% of the time. Use one 98% of the time. Use one 1% of the time. Use the other one 1% of the time. Do I care? No. What do I like? The first one. Right answer right away. No guessing. Everybody with me? Now, I want to do a couple more of these. Do you wish to see 4, 5, and 6 with all three methods, or do you wish me to choose one and follow it through? Choose one and follow it through? Which one? Me, decomposition, or the box? Decomposition is what you like? Great. Step 1, multiply. What is it?
40.
Multiply to negative 40. Add to what? Negative 18. What is that? Negative 20 and positive 2. 8p squared minus 20p plus 2p minus 5. 2p and b new. What's coming out of there? 4p. What's coming out of there? 1. 4p, 2p minus 5 plus 1, 2p minus 5. Write out the final answer. 4p plus 1, 2p minus 5. This type of question is why I don't use decomposition. Because too many of you will not factor out a 1. Even though I say factor out the GCF. The GCF of 1 is a factor of everything. So you can always take out a 1. Too many of you will forget that. And you will tell me it cannot be factored. That is why I don't like decomposition. Because too many of my students do not understand what factoring is. That you are dividing something out. That is lost on you. That is why I have stopped teaching this method and I use my method. But I don't care what you use. You guys seem to be happy with decomposition, use it. All right? If you're happy with the box method, use it. Should I do these two and then shut up? Well, we're almost out of time anyway. Your job today is the rest to the end of 167.